Next problem, problem number 9. An object in simple harmonic motion has amplitude 8 centimeters and frequency 0.5 Hz. At t initial moment of time, it has its most negative value. Write the function that describes the object's position. Again, as usual, you can write general equation for the unknown function coordinate versus time. This would be our amplitude times cosine omega t plus 50. 50 is initial phase at initial moment of time t equal to 0. Now we have value of the amplitude. It's given to us. It's 8 centimeters or 0.08 meters. We have frequency f, which is 0.5 Hertz. Not a big deal to calculate omega, and omega is equal to pi f. So our omega would be 2 pi times 0.5 Hertz. So you will have pi Hertz. So you can write your equation as x of t equal 0.08 meters times cosine pi Hertz times t plus 50. And the next what we have to do, we have to find our value for the 50. We are given that at initial moment of time, the object will have the most negative velocity. Because we are talking about velocity, we have to calculate velocity. And velocity is the derivative of the coordinate. So you have to take derivative of the cosine function. You will have the same amplitude first. Then sine being differentiated gives you cosine. Cosine being differentiated gives you negative sine. So you will have minus. You will have sine pi times t plus 50. And you have to use chain rule. So you have to multiply this by pi. So you have amplitude in meters, pi in hertz in 1/2. So overall you will have meters per second units. And we are given that at initial moment of time t equal to 0, we have the most negative value. The most negative value we will have whenever sine will take the biggest positive value due to the minus at the very beginning. So whenever sine is equal to 1, we will have everything. So what we can claim that sine of pi times 0 plus 50 has to be equal to 1 to ensure that we indeed will have the biggest negative value for the velocity. And it means that sine of 50 equal to 1. What angle gives you sine equal to 1? This angle is pi over 2. So we did find initial phase, and the remaining step is just to write the function coordinate versus time as amplitude 0.08 meters times cosine pi measured in 1/2 times t plus pi over 2. This is coordinate dependence we were looking for.